Hello everyone. Welcome to the course Python Programming for Beginners. In our previous lecture, we discussed about the overview, installation, and simple example of Matplotlib library. Now we will continue some other topics related to Matplotlib. In this lecture, we will see one of the concept coding styles related to Matplotlib. Yeah, this is the official website we already mentioned in our earlier lecture to get all the resources related to Matplotlib officially from this website. Okay, coming to the coding styles. Here we are having explicit and implicit interfaces. There are essentially two ways to use Matplotlib. The first one is explicitly create figures and axes and call methods on them. This is the style of object-oriented, simply we'll call it as OO style. Then another one, implicit way of calling. Rely on pyplot using pyplot method to implicitly create and manage the figures and axes and use pyplot functions for plotting. Let us demonstrate the two ways examples as part of coding styles. One is explicitly using object-oriented style, then implicitly using pyplot. The first example is related to object-oriented style as part of coding style. This is the program. Here first we have to import pyplot from Matplotlib, then creating it object as PLT, then use NumPy package, import NumPy as NP. Here, even in case of object-oriented style, we use pyplot.figure to create the figure. So first we are defining figure comma axis equal to plot.subplots. We are making figure size with the specific layout, height and width. Layout is constraint. Then we are taking x value with linear space 0 to 100. This is the sample data. Then we are plotting x.plot x. We are repeating x comma x. Then label equal to we are making linear. Let us also plot some data on the axis. Then that is normal x we are taking. Then second category we are taking x power 2. So again we are plot more data on the axis. X dot plot of x comma x power 2 label equal to this is the quadratic. Then next third plotting we are taking cubical data. So x power 3, here x power 2 that is quadratic, then x power 3 is the cubic data. X dot plot of x comma x power 3, here label equal to cubic. Then we are setting the labels. X dot set underscore x label is the name. Then for y label we are setting y label, x dot set underscore y label of y label. So here these are all the labels of x and y axis. Then you can set the title of the figure using set underscore title method. Ax dot set underscore title. Let us assume simple plot. Add a title to the axis. Then using the legend, the combination of various plots, you can discriminate using the legend method. So add a legend ax dot legend. Then whenever you can want to see the output of the plot dot show method. So actually this is the legend which discriminate all the plots. Here three plots we have taken: linear with blue color, quadratic orange color, then cubic green color. This is the x label what we use. This is the y label what we use. Now we can see this is the x-axis data. This is the y-axis data what we have taken. This is one of the example of object-oriented style plot diagram. So let us run this program lively and see the output. Yeah, this is the code what we explained. So open your Python ideal. So whatever the code we demonstrated. Let us run. First we have to import pyplot from Matplotlib. Its object is plt. Then import numpy. Import numpy as np. Then create figure and axis with a restricted size 5,2.7. Your layout is constrained. Then define x-axis data. Some sample linear space data we are taking 0 to. Then you can plot with different plots. First, a linear plot taking the as it is original data. Then you are taking whatever the x value, you are taking power of x, x power 2. This will call it as quadratic data. Then another plot, you are taking cube. Whatever the x value, power 3. That is cubic data. Here, first is linear, quadratic, cubic. 3 plots are taken. Then you are setting the label of x-axis. This is the using set underscore x label. The name is x label we have given. Similarly, set the label of y-axis, set underscore y label method. The name is y label. Then set the title of the plot or figure using set underscore title. For example, simple plot. Then define the legend to discriminate the 3 plots. That is linear, quadratic, cubic. For that use legend method. Finally, you want to see the plot, use plot.show. This is the code. What we explain. Now let us see the output. Here you can see. You can see all here. The first one is linear. Linear is blue color. The second one is quadratic. Here linear you can see this is like a line. Then quadratic orange color you can see the graph line deviation. X and Y values also are varying you can see. Then the green one is the cubic. Cubic one you can see the graph variation. It reaches to the top. Then X label. Here you can see set underscore X label. Here this is the X label. Then set underscore Y label. Here this is the Y label. Then set underscore title simple plot. Here you can see at the top. This is the simple plot. Okay, this is the object-oriented style plot as part of coding style. Now we will see the next one. The next style is using pyplot. That is here whatever we mentioned the 2 ways. Explicitly using object-oriented style, then implicitly using pyplot. Next we will see the pyplot example. Yeah, this is the example of pyplot style. Code almost same. Here you can observe the difference. Here you can see first you can import numpy, then import pyplot. Then same x you are taking linear separable space 0 to 100 sample data. Then figure size also we are making the same. Figure size equal to 5,2.7, layout equal to constraint. Then you are plotting. Earlier we used axis actually. Here plot of x comma x label equal to linear some data. So this is implicit. Here you can see directly we are taking plot dot with that object directly. Plot dot plot of. This is linear. Then again you are implicitly plotting plot dot plot of x comma x power 2. Here quadratic data. Then you are taking cubic data again using plot dot plot x comma x power 3 label equal to cubic. Then you are setting the x label plot dot x label, then y label plot dot y label. Here everything here you can see using plot itself. Implicitly this can be done using pyplot. Object-oriented style, explicitly we have to define. Now X and Y labels are set. Then the title of the figure, plot.title, simple plot, whatever you mentioned. Then to call the legend, to discriminate the three types of plots, plot.legend. But you can see the output is same. There is no change of output, only the representation, implicitly defining, explicitly defining. That is the only variation in object-oriented style and PipPlot style. Here you can see plot.show. The same diagram. There is no change of diagram here. Only the coding style is varies. Object-oriented to PipPlot. Object-oriented is explicitly you have to define. Then PipPlot style implicitly you have to define. This is the figure title. This is the legend. What we explained. A blue color linear, orange quadratic, green cubic. This is the X label. This is the Y label. So these are all the linear, quadratic, and cubic data. The graph is same as the previous program, what we explained. The only style of coding is varies. Okay, if you want to run this program also, let us run. Here you can see. So here, whichever the new that you can define, numpy is there, X is there, then we can define plot dot figure. Then plot dot defining the linear graph data. Then quadratic graph data. Then cubic data. Implicitly everything. Then labeling plot dot X label. Then plot dot Y label. Here you may think the maybe previous program only executed. Suppose, how can you see? Suppose simple plot, let us change the label using PipPlot style. Let us, now you can see, we change the label. Let us see. In the output, you can see. Now call the legend, plt.legend. Then finally, plot.show. Here you can see. Earlier title we are having simple layout. Now you can see simple plot using PipPlot style. We change the title. So this is the latest diagram. So output is same. The only coding style is changed. Object oriented to PipPlot. Object oriented is explicit, whereas PipPlot is implicit. That is the only difference. Then coming to, by considering helper function also, you can define our own function, then that function can be used during plotting. So making a helper functions in coding style. If we need to make the same plots over and over again with the different data sets, or we want easily wrap Matplotlib methods, use the recommended signature function as shown below. So import matplotlib.pyplot as plt, then import numpy as np. Here define your own function. Let us assume my plotter is the function def. Here we are taking axis data1, data2, parameter dictionary. Yeah, this is a helper function to make a graph. Whenever this function you want to repeat again and again for the new programs, you can call this method instead of defining every time. Then we are defining out value ax dot plot of data1, data2, then parameter dictionary, then which returns up. This is a simple function my plotter. This we will use during plotting. Now we would then use twice to populate two subplots using the same function. So data1, data2, data3, data4. Randomly we are defining. np.random number 4, 100. So make 4 random data sets, the same data. First we are defining figure with axis 1 and 2, plot.subplots 1, 2, then figure size, fixed size you are given 5, 2.7, then myplotter, this is the function what we defined. This is the function we defined previously. Myplotter, we are taking axis 1, this one. Data 1, data 2. Here data 1, data 2 means this same random number 4 to 100. We are making it as label marker type X. Then another time we are repeating the same function myplotter. Another axis we are taking axis 2. We are taking data 3, data 4. Marker with O style. That means this is object-oriented style. This is PipPlot style. Now let us see. Whenever you can see by using plot.show, these are all the outputs we got. So if you want to install this as Python package or any other customization, we could use one of the many templates in the web. So Matplotlib has one at mpl-cookie cut. So these are all the plots. The same with a different representation. Here you can see here this is the X style. This is the O style. Here this graph is filled with into mark. This graph filled with O. Here you can see circles. But the figure is same. The only marking is different. So here the same function is called. So the marking values are changed. Here into, here O, like that. The same purpose. So like that we can use even helper function also as part of coding style. Let us run this program. Making a helper function. Here Matplotlib already imported, NumPy already imported. Now you are defining myplotter function. We can this is the function myplotter. Now define data 1 to 4 with the random number generation 4 to 100 range. Then define the figure with two axes, ax1 and ax2. Now calling myplotter function, first set ax1 with data 1, data 2. This plot is marked with into rx. Then another plotter with ax2, data 3, data 4. Here data is same 1, 2, 3, 4 with the same random numbers. Here marked with O style, that is circle. Now plot dot show. Let us see the output. This is the output what we have seen. Even if you want, you can maximize. So this is the first one, first plot ax1 with into mark. This is ax2 with oval circle. That is the output. Okay, that is about coding style with object-oriented style and PipPlot style. One is explicit representation is object-oriented, implicit representation is PipPlot. In next lecture, we will see other interesting topics related to Matplotlib. Till then, stay tuned for latest updates.